Alright, hello. This is going to be Solidworks CSWA practice problem 8.13. If you want to follow along with the video, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. Today we're going to be making a cup with a handle. And this part, I actually had to re-record this because I got stumped on the part where you hollow out the cup, but I'll show you exactly how to do that later. This is actually a very interesting part, probably one of my favorites I've done so far. But first we will start with our, well actually first of all make sure your units are on MMGS down here. Then we're going to start with a base revolve. And if we need a revolve, we need a axis of revolution. So I'm going to start with a straight line down like this. Then we're going to go into an arc, a steep arc, till it's horizontal with the origin, and I'll finish off with a horizontal line. Also, quick disclaimer, be very careful. If you look into section AA view, notice that it's an offset revolve because it's a hollow cup. So there's outside and inside. And if you look closely, you'll see that the dimensions are all referencing the outside surface, not the inside. So we are going to be drawing the outside, so just be careful of that. And so let's start our dimensions. The total height of this part is going to be 115. Now let's establish the total width. Now the total width will be the bottom of the cup, which is going to be a diameter of 100. So I'm going to click this far left corner. I'm going to hold onto the center line, and then I'm going to drag it down. That's a unique tool in SolidWorks, which actually allows you to kind of have a preview of the total revolve. Really neat feature. And we're going to do something very similar on the top side. We're going to click on this top point, hold the center line, and drag it up. Oh, I did that wrong. Let me back. Click on the top point, hold the center line, drag it up, and the top diameter is 75. So I'll make this 75. Now let's add a fillet of radius 10 to this bottom corner here. Select OK. And you'll see that all the tangent, well actually I believe I have my constraints turned off. Yes, I actually have sketch relations turned off. I don't know why I had them turned off. That's weird. Alright, let's go back to the sketch. Now you can see sketch relations. Anyway, so let's dimension this steep arc, and it should be a radius of 85. And you'll notice in the section view a weird dimension, which is the 50. Now that 50 is actually the 50. Oh wait, oh no. I guess you don't need to constrain the center point because it already has tangent relations. So you can just ignore that. Oh, no. This is actually incorrect. I'm going to delete this arc right now. I forgot that there's actually supposed to be a diagonal line. So it's like you make a steep arc, like so, but then there'll be a diagonal straight line like this. The drawing is a little deceptive. It all looks like one arc, but it's not. So let's add our tangent relations between diagonal line and arc, and then the diagonal line and the fillets. So it's all tangent. And now the angle dimension between diagonal line and horizontal this is going to be 75 degrees. And then let's go back to the arc. So radius is going to be 85. And now you notice the center point is actually not fixed. So that's where the 50 comes in. So as I was saying, in the section A view, that 50 dimension is referencing the distance from center point to the base. So we can fix this center point of the steep arc. And now you should have a fully defined part, or not part, but sketch. And the last step here is to do the offset. So we'll do this. We're going to offset it by 4 for 4 thickness. And like I said before, we were dimensioning the outside surface. So we're going to reverse the offsets to the inside, and we're going to cap ends with lines. Select OK. Now all that's left are the R1 fillets. And it's going to be at the capped end corners. In order to fully constrain it, all you have to do is just make sure that this line is vertical and this line is horizontal. Now you have a fully defined revolution sketch. Actually, is it fully defined? Should be fully defined. Let me check again. Nope, it says underdefined. Wonder why it says underdefined. Underdefined. Oh, what is this? The corner point. I don't know. Oh. Interesting. What if I delete this corner point? Now we have a fully defined sketch. Interesting. Okay. So, okay. Sorry about that. So we're going to revolve this feature. Choose this as the axis of revolution. Select OK. Now you have your base cup. And now we're going to start a new sketch in the front plane. And we'll start with the center line, like so. Now, in the front view drawing, it actually tells you to create the sweep so that it's connected to the center line like this. And you may think this is strange because sweep is supposed to be for the handle, which only exists on the outside. But the reason why they did it like this is because they don't want any gaps in between the handle and the cup. And so the only way to do this is to extrude a sweep through the cut. And obviously the problem, that solves one problem. You get rid of the air pockets, but then it creates another problem, which is that you'll have, excessive sweep in here. But to solve that, you're going to do a revolve cut inside of the cup to hollow out the cup and get rid of the excess sweep. And I'll show you what that looks like in a second here. So you start with the horizontal line. Let's dimension the distance from the top as being 18, like so. Let's add a diagonal line like this, and then let's add another diagonal like this. Now, these two diagonals are actually perpendicularly constrained, so we'll do that. It doesn't tell you directly, but it is implied. If you look in the detail B view, it's pretty clearly perpendicular, or otherwise they would have added other dimensions. And we will add an angle between the diagonal and the horizontal as being 110 degrees. Total length of the diagonal side. Oh, not like this, not like this. Total length of the diagonal side, like so, will be 40. And there's also going to be a fillet of 12 for both of these corners. Select OK. Actually, before I do those fillets, let me add a dimension that I missed. So the dimension between this left side corner and the very bottom is going to be, let me see here. That should be, oh no, the dimension from this bottom, the left side corner and the center line is going to be 75, like so. And then we'll add our fillets. And the reason I had to do that is because the corner here disappeared once I added the fillets. So now we add the fillets, corners disappear, and then there's your path. So now all we need is to create a sketch in a perpendicular plane, which we'll do in the right plane. Just draw an arbitrary circle. Its diameter is going to be 12. Then we're going to select the center, select the line, and we're going to click Pierce. Select OK. Now the bead is in the string, and we're going to continue with our sweep. It selects the circle as the profile sketch, and for the path we'll select the line. Select OK. And now you can see, actually I'll change the transparency of the cup just so you can see. If you right click on the revolve, and then click change transparency, now you can see that there is an excess of sweep inside. And like I said before, we need a revolve cut. And to do that, we're going to use convert entities. So first of all, I'm going to create a sketch in the front plane. And because we only need to hollow out the inside, but without breaking the original revolve of the cup, we'll only select the inside as being for convert entities. So I'll convert entities everything on the inside. Actually, let me change the transparency. Transparency is kind of throwing me off here. And I'm just gonna click on the revolve sketch instead. And I'll make it shown so I can see the lines. And then we'll go back to convert entities. And we'll select the outside lines. Or the inside lines, sorry. Inside lines. All the inside lines like this. Select OK. Then I'll connect a horizontal line. Well, actually, first of all, let me add a center line. Since this is a revolve cut after all. Center line like this. Then we'll connect a horizontal line. we go straight all the way up. Actually, I will connect another horizontal to the center line, go all the way down, close the contour, and then I'll change transparency again just to show you. So this is your closed contour, and now this is going to be revolved and cut everything inside, so you won't have any of that excess sweep. So we're going to go to Feature, Revolve Cut, 368 degrees, select OK. Now turn off the transparency of the revolve. So now you can see the original cup is not altered at all. The original cup is not altered at all, but now all the excess sweep from the handle is gone. And is this it? Yes, I believe that's the entire part. So let's check the answer. So let's go to Evaluate Mask Properties. And you should have an answer of 136,136 cubic millimeters for your volume. So hope you learned something from this video, and I'll see you in the next one.